Okay, we're going to go ahead and talk about inequalities just in general. First of all, an inequality isn't really any different than an equation in the process that you use to solve. The main difference is an equation uses an equal sign to show that both sides are equal, and an inequality shows that both sides are not equal. So they are going to use, for example, what you see on the screen here, a greater than, less than, or the greater than or equal to, which looks like that symbol with a half of an equal symbol underneath it, or less than and equal to. Or it might just ultimately say that they are not equal. So an equal symbol with a slash through it. Okay. Some examples that you are going to see when I'm talking about, for example, 4 and 9. We know those are not equal, right? If I have $4 compared to having $9, it would not be the same amount of money. So we know that 4 is less than 9, so 9 is greater than 4. We put the greater than less than symbol, opening up to the greater number, pointing at the smaller number. This works for whole numbers like 4 and 9, works for rational numbers like the decimals that are after the letter B. 5/10 is greater than 45 hundredths. It works for integers like -3 is less than -2 because we talked about this during the integer unit. The further away from 0 into the negatives, the smaller it is. The closer to 0, the greater the value. -6 and 1/10 is equal to -6 and 10 hundredths because the number of zeros after numbers after a decimal don't change the value, they just hold a place. And then again, if you looked at 12 and 4/10, that would be greater than 12 and 4/100 because the 0 is between the decimal and the digit, not just simply after it. So with that said, this can be applied for the same solving inequalities where they simply tell you a variable on one side. For example, number 2 down here says 12 is greater than f. Okay, if f is equal to 3. So if f was 3, then you would have 12 is greater than, for example, 3. Okay, f could be anything that is selected by someone. It could be 2 and 12 would still be greater than 2. It could be 9 and 12 would still be greater than 9. So plugging in the values and then again checking to make sure that it is in fact a true statement is important. For example, on number 3, they're telling me D is 3. So what they're saying is 3 is greater than 3. This is not a true statement because 3 is equal to 3. Okay? Therefore, you would say that is not true. 3 is equal to 3. Therefore, if D equals 3, 3 cannot be greater than D. It would have to be equal to. Okay, so you would simply work this out by checking your solutions by plugging in the value that the variable is worth. And now, the other part of inequalities is how to graph them. So when I'm looking at this and I'm trying to graph an inequality, there are 2 ways to put this onto a number line. If it includes, so greater than or equal to, you would have a closed circle. Okay. If it does not include, it would be an open circle. So an example I would see is a symbol that is greater than or equal to or less than or equal to. If it is not including it, then it's simply going to be the greater than and or less than symbols. So for example, on number 5, if I was going to go ahead and graph this, I would want to include the number 5. So I would fill it in with a solid dot, okay, on the number 5. And I'm looking for 5 to be greater than anything that x could be or equal to it. So if it was 5, it would be equal to it. But the direction that the arrow is pointing has to make the rest of the statement true also. So if 5 is going to be greater than something that is x, if x is not 5, then I need to pick numbers that are less than 5. So if I point my arrow this direction, okay, I could put any of these numbers in for the place of the x, okay, and it would still be true. So is 1 less than or equal to 5? Yes, 1 is less than 5. If I pick 2, 2 is, yes, in fact, less than 5, okay? So by drawing the arrow and pointing the direction of the values that are less than 5, I have correctly graphed this, okay? If I was going to show an example of not including, I would pick question number 10. K is greater than 11. Well, I don't want it to include, so I need an open circle on 11. Okay, not filled in, but open. And now I want to point the direction that makes it a true statement. So if K is greater than 11, I want the arrow pointing the direction of numbers that will be greater. If I put in one of the numbers along that line, okay, like 12, 12 is greater than 11. Yes, it is. Therefore, my arrow is going the right direction. Okay, so you can prove this on any of those types of problems simply by plugging it in and actually reading it out. Okay, so a quick little intro if we're still taking inequalities but actually trying to solve an actual equation, all one step at this point. Inequalities can be solved just like an equation. Same exact rules apply, but with a few exceptions. Not many, but a few. So the goal when solving an inequality is to isolate the variable. Same as a one-step equation, okay? Use the inverse operation to make this possible. Isolate the variable by using inverse operations or the opposite operation, okay? Number 2, the inequality must remain balanced. So whatever we do to the right, we also do to the left, okay? And rule number 3, this is the only one that is different. When you divide or multiply by a negative number, the inequality sign is flipped. This is the only rule that is different. And notice that it says when you multiply or divide by a negative number. Okay, so this only works when I'm dealing with a coefficient that has a negative sign. Okay, so do a couple of examples on this one. We're going to just take number 1, nice and easy here. The operation that I would solve first would be, I would take the inverse of the constant. Okay, it's a positive 5. I would subtract to make it go away. That leaves me with n on this side. Okay, and rewrite everything. On this side, it would be subtracting 5. So if I were to do that, 16 minus 5 is 11. Okay, so I'll rewrite the work there. And now I have n on one side, variable isolated, constant or the value of it on the other side, and an inequality symbol in between. Okay, easiest way to check, if I put 11 plus 5, okay, put the symbol in between there, punch that in, I would end up with 16 on both sides. Okay, now with that said, I'm going to create a number line to represent this. Okay, if I'm saying that n is less than or equal to 11, 11 should be on my number line. Okay, and like normal number lines, I'm going to put the 10 on the left, 11 on the right. Okay, just as long as I have numbers written on there. Okay, obviously the circle is going to go on where the 11 is, and I'm going to fill it all the way in because this is and equal to. Remember, it includes. The direction the arrow will point will prove the statement true no matter what I plug in for n. So let's say that I point it towards the 10 and the 9. Now let's read this. If I said 10 was here, is 10 less than 11? Yes, it is. So my arrow is pointing the correct direction. Okay. Going into an example now of the only difference between inequalities and equations. Okay. I'm going to do this one-step equation right here where I have negative 4k is less than or equal to 22. The operation I see is multiplication, so I will be dividing. I am dividing by a negative on both sides, okay, which means that the sign is going to flip. That means that I'm putting the sign the opposite direction. I can put the sign down first because I know the sign is going to flip, since that is the only rule that's different. Okay, if I divide 22 by a negative 4 on this side, I'm going to end up with a negative 5.5. Okay, on this side, the 4s and the negative signs cancel each other out, and I'm simply left with a k. Okay, so again, on this number line, I would have 5.5, a negative version of it. I could label this any way I would like. Maybe I'm going to go ahead and put a negative 5.4, okay, a negative 5.6, okay, or I could have done 6.5, 4.5 with negative signs. It does include, so I need to fill in, and I need to make sure to point it the right direction. So I want negative 5.5 to be less than whatever k is. Remember, it's going to be less, that it's got to be further away from 0. Okay? So if I did negative 5.6, where the k is that greater than negative 5.5? Okay? Well, the further away you get, the less it is. So actually, in this case, that is incorrect. Okay, so here's an excellent example of proving that we went the wrong direction. Now, try the other one. If I put a negative 5.4, is 5.4 greater than negative 5.5? Okay. Well, the closer you get to 0, the greater the values. So yes, this is the direction I would want the arrow to go. Okay. And again, I left the check your work box empty, but I could easily check it by putting a negative 4 here, replacing the k with the negative 5.5, and having that be less than or equal to 22. Using my calculator to punch in, and it does in fact give me a 22 on this side. 2 negatives make a positive, and 4 times 5.5 equals 22. So hopefully that helps you. And the same rule applies for two-step equations. So this is how to graph inequalities. This is how to solve one-step inequalities, which is the same exact rules as one-step equations, with the exception of when you divide or multiply by a negative, the sign will flip. Good luck and enjoy your spring break.